Okay, this video is simply about switchgear from the company Eaton. We have medium voltage switchgear, which is not exactly similar to the medium voltage switchgear also produced by the company Alphanar. So we have, quite simply, medium voltage switchgear, which consists of a set of bays or feeders or a set of modules, which are a group of cells lined up next to each other. I will start by taking just one cell from them. Of course, we will explain this video. And every day, just because every day I will talk about a specific topic. So now I have taken just one bay or one feeder and worked on it. All right, look at the feeder I have. As you can see, it consists of 3 parts. Let's focus together. Here it is. All right, it consists of 3 parts: the upper part, the middle part, and the lower part. At the same time, you can divide it into 2 sections, the front and the rear, which are the front part and the back part. All right, good. Now, let's take a look at the upper part, which is the top section. It includes the front section, where the control circuits and protection circuits are located. And the rear part, or the rear section, is the back part, where the bus bar is located. All right, now the middle part, here, the front section of it is where the circuit breaker or the electrical breaker is located. And the rear section contains something called the current transformer. Moving down to the last lower part, the bottom bar, the front section contains the earth switch and the voltage transformer, and the rear part contains the massive battery that is located there. The cable or cables that are connected there. All right, let's take a look at this. Here is the first bus bar section. This is the first section that contains the bus bar. As you can see, this bus bar section is sufficient for only one feeder. As you can see here, there are a series of openings where another bus bar can be placed next to it of the adjacent cell, and both are assembled together. We then install screws here, or rather, you have slightly larger screws, and they are tightened to reach a specific torque level. All right, that's great. Now here we have this section, which is coming out of the bus bar. Of course, the bus bar is originally copper colored, like copper itself. All right, Engineer Rashad, this color on it is not the actual color. It's an insulating material we call Recom. This is an insulating material called Recom. All right, very nice. This is the middle section, which is the circuit breaker section, and it is of the withdrawable type. Circuit breaker, meaning it can be pulled out. And here is the lower section where the earth switch is located. Oh, sorry, here is the earth switch and the cable section, the cable termination. All right, I'm just showing you today, for those who haven't yet seen how the earth switch is operated and how the interlocking works. I'm not explaining anything yet, just introducing you to the topic, not how it works. All right, here is the cable termination, as you can see. And here is the voltage transformer that measures the voltage, or the voltage transformer. All right? Very good. Here is the upper part from above. Here you have the low voltage compartment, which contains the protection circuits and control circuits. Up here above the cell, we have what we call the integral arc chamber. This is like a chamber, and its surface here is very weak. Imagine with me that when an operator is working, and God forbid, a short circuit or flashover occurs. In this area, gases are present. These gases are, of course, enclosed by your panel. The gases start to compress, and the entire body of the panel is strong except for this weak part above. If it manages to break this part, the spark or the gases or all of that will go upwards, thus protecting the operator or the maintenance personnel inside the room from an explosion occurring in their face. Even if they are wearing Cat 4 or other types, Cat 4 is a type of safety gear worn by the operator while working, whether in maintenance or operation. So this is the switchgear. As you saw, Engineer, it is an air-insulated switchgear, referred to as AIS, air-insulated switchgear. What does air-insulated switchgear mean, Engineer Rashad? As you saw, the bus bar is in the air, around an insulating material called RICM, no problem. The switchgear cables, everything is initially present, unlike the gas-insulated switchgear where all of this is inside tubes. These tubes contain SF6 gas, meaning you won't be able to see the bus bar. The bus bar is inside a tube, and this tube is sealed. Also, this tube is connected to the breaker through another tube, and the breaker is connected to the cable through a third tube. In the end, you only see the cable coming out like this. So everything is immersed or submerged in a gas called SF6 gas or sulfur hexafluoride, which is sulfur hexafluoride. This is referred to as air insulated switchgear. All right, what does the term withdrawable circuit breaker mean, engineer? It means a breaker that can be withdrawn. Here I have something called a trolley, just like a children's trolley or others, and it has wheels. The breaker is mounted on it. In the position you see here, the breaker is disconnected from your panel so that you can perform maintenance operations outside, conduct tests, or troubleshoot. All right, so here you have withdrawn the breaker outside and the maintenance is being done on the cell. Do you necessarily have to disconnect the bus bar or anything else with you? No, of course not. The breaker is with you outside. Great. Now you want to start the system or return the breaker after finishing your maintenance. You start, as you saw, to take it back. Of course, I will still talk to you about this story. The idea here, as you can see, was like this. This lock was here to protect the breaker and prevent it from slipping off the trolley while you are working on it. So now you want to release it from here. You will push these levers inward, then start to push the breaker inward. This way, you have installed the breaker in its housing. You install your plug. I will also tell you the story of this plug, but not now. You install your plug and pull the trolley. But all of this, I am giving you a general overview. Take a look at it. Just like that, exactly. So the breaker in the position you see here is called rack out. It's like a drawer that is completely out, previously known as disconnect. Now it's called rack out. If you want to insert the breaker, rack in to start connecting electricity to a bus bar or draw electricity from a bus bar to deliver it to a load, you have something called the insertion hole. You start by inserting a handle into it and begin to turn it, starting to insert the air circuit breaker like a drawer, just like you would insert a desk drawer. You can pull it. Reference office, Bra Pure and Cup Meds Connect. You place it in its slot, but you leave it open like that. It's called a rack. Insert it inside, what's it called? It's called a deep rack, right? Of course, you saw that. Here's a breaker going inside. What's it called? It's called a rack, right?